In this type of exercises, we're going to use the change of base formula and the properties of logarithms to solve the following equations. Because we want to solve the following equations, that means we want to find the value of x. So to do that, we first have to notice that the x variable is in the exponent of inside of logarithm, meaning that to solve an equation, we first have to get rid of the variable in the exponent. So we can use the power property to get the exponent to be not an exponent anymore. So by using the power property to this logarithm, I can rewrite this expression as the exponent times logarithm base 5 of 8. Now notice here that this term is multiplying the logarithm, meaning that if I know that I want to isolate x and this logarithm is getting in my way, so I have to divide everything over that logarithm, meaning that this equation turns to look something like this. Then lastly, the 2 is getting in my way, so I'm just gonna do x equals 9 over logarithm base 5 of 8. Now, if I would ask you to get the exact value for this expression and ask you to calculate it with a calculator, remember, you can only plug into the calculator logarithms of base 10 or base e, meaning that we would have to make a change of base in the denominator, that is, a change of base where the logarithm is. So this can be rewritten as x equals, I'm going to change it into base e. So this is, here's the formula, if you don't remember it, is logarithm of the new base of the new argument, over logarithm new base of the previous base. So what I did here is just to apply a change of base to the logarithm in the denominator. So then, if you want to find the exact value, you only have to plug this into the calculator and that's it. That is what Alex asked you to do. If I ask you to do this, here's where you leave everything. I don't need the exact value. Let's do another example. Again, the variable is in the exponent and I don't want the variable to be an exponent, so I'm going to use the power property to put it down. From there, because I want to solve for x, I want to isolate this term, meaning that I have to divide everything by the logarithm. And then, because this 5 is getting in my way, I'm going to pass it to the other side. Lastly, this x is negative and I want everything to be positive, so I'm going to multiply everything times minus to make it positive. So this is plus, this is minus, and this is plus. Then, because I want, if Alex asks you to do this, you will have to find the exact value, meaning you will have to apply a change of base to this logarithm of base 3. So I'm going to change it this time to logarithm of base 10, meaning that the denominator of this fraction would be logarithm base 10 of the argument over logarithm base 10 of the previous base plus 5. And you can plug that into the calculator and that's it. Next one. Again, I'm going to apply the power property to put down the exponent of this logarithm. Then the logarithm is getting in my way of isolating the x, so I'm just going to pass it to the other side, dividing. Then the 3 is getting in my way, so it's going to pass to the other side, subtracting, and lastly I'm going to divide everything over 2, or in other words, multiply everything times 1/2, meaning that this is logarithm base 2 of 9 minus 3/2. And if I want to apply a change of base here, I'm going to do it with base 10 again. So this logarithm can be rewritten as logarithm of the argument over logarithm of the new base of the previous argument of the previous base, and that's it. Another example. In this case, notice that not only is the exponent here, but I have things getting in my way. So first things first, I'm going to apply the power property. Minus x plus 1 times logarithm base 7 of 5 minus 3 equals 7. The first thing that's getting in my way is these two terms are multiplying each other, but this one is subtracting. So I'm going to add a plus 3 on both sides to cancel it. Then I'm going to pass the logarithm dividing. And then I'm going to pass the 1 subtracting. And because I want my x to be positive, I'm going to multiply everything times minus 1. So I get in return this expression. And if I want to change the base of this logarithm to plug it into the calculator, I can do it like this. Don't forget, I'm going to use natural logarithm this time. That is logarithm base e. So this is ln of 5 over ln of the previous base plus 1. And that's what you plug into the calculator. And that's how we use properties of logarithms in change of base to solve some equations.